So imagine trying to choreograph like a perfect ballet, but with 5,000 dancers.
Well, it sounds like a nightmare.
Right. And now imagine the stage is made of deep mud, the weather is violently changing every 10 minutes, and oh yeah, half of those dancers are driving 50-ton bulldozers.
Yeah, that changes the stakes a bit.
Just a little. And if anyone misses a single step, I mean, the consequences are literally a matter of life and death. And that is the everyday reality of a modern mega construction project.
It really is. It's this chaotic environment that demands absolute precision from, inherently unpredictable human beings. It is essentially the ultimate collision between theoretical physics and messy human reality.
Exactly. And navigating that exact collision is our mission for today's deep dive. We're looking at a really specific, honestly fascinating stack of sources today.
Oh, definitely.
We've got the rigorous health, safety, and environment, or HSE specifications, for a massive FIDIC Red Book construction contract. So specifically, we're dissecting the HSE requirements, the site rules and regulations, and the life-saving rules.
And just for some quick context for you listening, a FIDIC Red Book contract is basically the gold standard framework used globally. It's for these major, highly complex construction and engineering projects.
Right.
It's the playbook used to build, like, the world's largest infrastructure.
But thing is, we aren't just here to read off a list of hard hat rules. That would be boring. We want to look at the psychological, the cultural, and the systematic architecture that's required to keep thousands of people alive in these high-stakes environments.
Yeah, we're exploring how safety is engineered before a single shovel even hits the dirt.
Before anyone even arrives on site. And that engineering, it starts with this massive preventative architecture.
Exactly. The project's DNA is essentially sequenced for risk from day one, and the core of this whole thing is the HSE Management System, which is driven by a process called HEMP.
HEMP, which stands for the Hazards and Effects Management Process, right?
Right, HEMP. And the sources outline it as this incredibly comprehensive tool. It forces the planners to look at the entire landscape holistically.
So they aren't just looking at the tools.
No, not at all. They have to map out local environmental conditions, structural demands, and incredibly specific individual work tasks. And then, once they have all that, they categorize every single element using a risk assessment matrix.
Or a RAM.
Yes, the RAM. The RAM is the filter. It sorts every potential hazard into low, medium, and high risks.
Okay, so where a task lands on that matrix dictates exactly how much bureaucratic and practical friction is required before the work can, legally begin.
That's the perfect way to put it, yes.
So if we look at a low-risk task on the matrix, say, I don't know, a crew sweeping up debris in a non-hazardous staging area.
Sure, simple enough.
Yeah, it's mostly about routine. You rely on standard, previously established controls. You ensure you have a competent worker, some basic supervision, maybe a quick daily team talk.
Yeah, low friction.
Yeah.
But the moment a task hits that high-risk threshold on the RAM, let's say, executing a complex dual crane lift of this massive steel module in high winds.
Yeah, wow. Yeah.
A completely different protocol is triggered immediately.
And this protocol requires what the documents call the bow tie methodology and a formal ALARP determination.
Right, ALARP.
And ALARP stands for as low as reasonably practicable. The philosophy behind ALARP is, I frankly think it's brilliant.
It really is. It changes the whole mindset.
Because it's the complete opposite of a box-checking exercise. The rules dictate that the team cannot just look at a plan and say, yep, this looks safe enough.
No, they explicitly have to ask, what more could and should be done to control these risks?
And they have to actually prove their work.
Exactly. To demonstrate that you have genuinely reduced the risk to ALARP, you must document all the mitigation options you even considered.
And here is the kicker, which I love. You are deliberately required to consider an option that is considered one step too far.
Yes, the one step too far rule.
Which is just a fascinating cognitive exercise to me. You have to intentionally pitch an absurdly overprotective idea just to find the boundary of what is actually practical.
You have to find the absolute limit.
Right. Like if you are tasked with painting a massive suspension bridge over a river, using standard scaffolding and harnesses, okay, that's good. Adding safety netting underneath, that's better. But building an entirely enclosed, climate-controlled temporary warehouse around the entire bridge just to paint it safely.
You're one step too far.
Exactly.
And by forcing the engineering team to formally document that one step too far option, the system basically proves they haven't just settled for the easiest or cheapest safety measure.
They really pushed it.
They have pushed the boundary mitigation right up to the very edge of practicality. And the contract is absolutely ruthless about this.
Really so.
Well, it explicitly states that if there is any uncertainty during the risk assessment, the most conservative assessment always wins out. No exceptions.
Wow. I can see how that ALARP principle translates perfectly into everyday life, honestly. Like for you listening, when you are managing a risk in your business, maybe rolling out a controversial new software platform across your company, ask yourself, what is one step too far in risk mitigation?
Right. Because if you don't know what too far looks like, you probably haven't pushed your safety nets far enough to begin with.
It totally forces you to define your parameters.
Yeah.
But there's a catch here, right? Because you can do all the ALARP analyses in a sterile boardroom you want.
Oh, yeah. But out in the mud, reality shifts constantly.
Right. Relying purely on a master blueprint feels like, well, it's like trying to perfectly choreograph a football game before the kickoff. You can draw up all the plays, but the second the ball is snapped, the defense blitzes, someone slips on the wet grass, the wind changes direction.
It's dynamic chaos.
It is. The master plan just isn't enough to keep people alive when things change that fast.
The authors of these specifications absolutely know that, which is why the overarching ALARP architecture is paired with highly tactical daily field tools that are strictly required by the contract.
So you don't just rely on the static plan.
Right. You rely on continuous dynamic risk assessment right there on the ground.
Which brings us to the job hazard analysis. And this requires the crew to break down the specific sequence of work for that specific day, under that day's specific conditions.
And even more tactical than that are the immediate mental tools they use, like the 3 whats.
The 3 whats. I like this one.
Yeah, it's simple. What can go wrong? What can cause it? What can be done to prevent it?
Elegantly simple.
Elegantly simple, but it forces immediate mindfulness right at the work front.
My favorite tactical requirement in these documents, though, is the step back 5.
Oh, yes. The step back 5 is crucial.
The contract actually mandates that the work team takes 5 minutes on-site, like literally just standing there, tools down, doing nothing for 5 minutes, to look at the physical environment and identify hazards before starting work.
It perfectly bridges the gap between the boardroom's theoretical ALAR analysis and the shifting physical reality of the actual site.
It's a forced pause button.
Yeah.
And honestly, we could all use a step back 5 before we, hit send on an angry email to a colleague.
Oh, absolutely.
Just forcing that 5-minute pause totally changes the outcome.
It creates a necessary buffer between intention and action. So now we have this massive theoretical architecture, and we have the tactical boots-on-the-ground tools. But we need to look at what happens when these perfectly designed rules collide with an existing physical reality.
Right, because many of these FEI megaprojects aren't just built on an empty patch of dirt in the middle of nowhere.
No, they are often being integrated into massive, already operating facilities.
Which means your project's brand new safety rules are suddenly crashing headfirst into the host facility's legacy safety rules.
Exactly. Like if a contractor wants to run 12-hour shifts because that's their corporate standard, but the existing oil refinery only permits 8-hour shifts to prevent fatigue.
You have a really dangerous point of friction.
You do. And to manage that collision, the contract mandates an HSE Site Rules and Regulations bridging document.
The bridging document, which does exactly what it sounds like.
It really does. It forces both entities to map out their respective requirements side by side. They have to explicitly identify any gaps.
And state exactly how those gaps will be closed before any work even begins. It basically guarantees everyone operates from a single, unified playbook.
Right. And what's truly remarkable about the site rules outlined in these sources is just their sheer breadth.
Yeah, they go way beyond the standard physical safety you'd expect. Like when we think of construction safety, we picture, tying off your harness on scaffolding or wearing a hard hat or basic fire prevention.
The basics.
But these bridging documents mandate strict controls for things like dust emissions to protect surrounding communities. They have detailed protocols for the protection of local marine environments.
And comprehensive mitigation for ergonomic and even psychological hazards.
Which is wild. You might wonder why a heavy construction contract is deeply concerned with psychological hazards.
It's because the system recognizes that fatigue, immense stress, and poor mental health directly degrade a worker's situational awareness.
A distracted worker operating a crane carrying a 10-ton steel beam isn't just having a bad day.
No, they are a catastrophic risk to everyone in a 100-yard radius.
So the system treats the human mind as a critical operational component, and it tries to stabilize its operating conditions as much as it possibly can.
Exactly. So we've established these strict bridging documents to control the physical environment and the minds within it. But all of these rules still assume a relatively inert construction environment.
Right.
What happens to this massive bureaucratic safety net when the environment itself suddenly comes alive?
And that brings us to commissioning, which is universally recognized as the absolute most dangerous phase of any mega project.
Without a doubt.
This is the moment the site shifts from being a collection of, dead steel, concrete, and unpowered wires into a live, breathing plant.
It is a profound transition. The entire risk profile changes literally overnight.
Reading through the protocols, the best analogy I could think of is that it's like waking up a sleeping dragon.
I like that.
You have spent 4 years building this massive, dormant beast, carefully chaining it to the floor. And commissioning is when you start pumping blood into its veins.
Yeah.
You introduce highly volatile hydrocarbons, high-voltage electricity, pressurized steam at hundreds of degrees.
Suddenly, the beast can breathe fire.
Yes, you have to test every single chain, every single valve, before it fully wakes up.
The sleeping dragon analogy is spot on because when you introduce those lethal dynamic elements into the system, standard construction rules are just no longer enough. The contract requires an entirely separate induction training program.
Wow.
And a totally distinct HSE management system specifically engineered just for commissioning.
And the physical protocols to manage that dragon are incredibly rigid.
Right.
For example, the documents heavily emphasize the red spade procedure.
Yes, the red spade. And we should clarify, this isn't just a digital lock or a warning sign hung on a valve somewhere.
Right, it's a physical absolute. A red spade is literally a solid metal plate, often with a handle shaped like a spade, painted bright red, that is physically bolted between two pipe flanges.
It completely mechanically blocks the flow of hazardous materials.
So if a worker is in a confined space performing a final weld, and someone in the control room accidentally opens the wrong valve to flood the pipe with high-pressure steam, that scheme hits the red spade and stops cold.
It gives the worker an impenetrable physical barrier against catastrophic human error somewhere else on the site.
Which is terrifying but amazing.
They also implement incredibly strict alarm and trip management to ensure that the newly activated safety sensors are perfectly calibrated.
Right.
And they exert massive oversight over temporary bypasses, which happen when a critical safety system has to be temporarily turned off so the engineers can test another interconnected system.
Which introduces a massive problem, I would think, with all these shifting variables, bridging documents, closing gaps, transitioning from construction to live commissioning, managing temporary bypasses. How do they keep track of who's actually accountable?
That's a lot to track.
It feels like the sheer volume of paperwork would bury the site and obscure who made what decision.
That's where the documentation standards come in. The specifications require that all products, documents, and records strictly comply with ISO 17200.
So in a project this massive, paperwork isn't just bureaucracy, it's a structural component, just like the concrete.
Exactly. ISO 7200 is an international standard for technical product documentation. It dictates exactly what data fields must exist in every document header.
Okay.
But more crucially, it mandates unbreakable digital e-signatures by the document creators, the reviewers, and the final approvers using verified software.
Because the stakes here are enormous.
Right. If an engineer decides to quietly alter the pressure rating on a pipe schematic to save time, and no one officially signs off on that change, the pipe could literally burst during commissioning.
Wow.
ISO 7200 ensures that a digital signature locks that document down completely.
If the schematic changes, alarms go off. You cannot quietly bypass procedure without leaving a permanent digital fingerprint. The paperwork is engineered just as tightly as the steel.
So if we look at the whole picture, we have this incredible multi-layered safety net. We have the ALARP matrix, bridging documents, physical red spades, and ISO 7200 digital fingerprints.
It's a lot.
It is. But the system still has a fundamental vulnerability. At the end of the day, all of this architecture relies entirely on human compliance.
And that is the million-dollar question. How do you get 5,000 individual contractors who might work for 40 different companies to actually follow these rules perfectly every single day?
The industry's answer to that vulnerability is absolute standardization and simplification at the ground level. The text outlines 9 standardized life-saving rules.
And the sources are incredibly strict about this. They explicitly state that these 9 rules cannot be modified, tweaked, or substituted by any subcontractor, period.
Right. And the reason for that rigidity is the reality of the modern construction workforce, which is highly transient. Like a welder might work for contractor A in January, subcontractor B in June, and contractor C in October.
So if every company has a slightly different definition of what safe confined space entry means or what proper fall protection looks like, you create cognitive friction.
You get confusion. And in this environment, confusion gets people killed.
So by standardizing the 9 life-saving rules across the entire industry, the safeguards become a universal language. No matter whose logo is on your paycheck, the core rules of survival are identical.
But, having the rules is only half the battle. You still need people to actually report when things go wrong. And this is where we get into the most counterintuitive part of the entire HSE specification.
This part really challenged my assumptions, to be honest.
Yeah.
To get people to comply, the contract forcefully mandates the creation of a blame-free culture. It specifically states that all contractors must report non-conformances and near misses in a completely blame-free environment.
It's a concept that often faces a lot of resistance at first glance.
Oh, I have to be honest. A blame-free culture on a highly disciplined, high-stakes construction site sounds totally contradictory. Doesn't that just invite carelessness? Like, if I know I won't get chewed out or fired for dropping a heavy wrench from 3 stories up, what is my incentive to be careful? It sounds like accountability-free, not blame-free.
That is the totally natural reaction. But when you look at the mechanics of the system, you realize the blame-free culture is actually the secret weapon of the entire architecture.
Wait, really? How does that work?
Because the ultimate goal of the management system isn't to dole out punishment. Its goal is to gather data. The text sets a very specific, aggressive metric for success. It's about driving down the TRCF, or total reportable case frequency, to less than 2.0 per 1 million man-hours.
Okay, let's do the math on that. For every 1 million hours worked by the collective crew, you cannot have more than 2 injuries that require medical treatment or time away from work.
It is a razor-thin margin.
That is incredibly tight.
And to hit that margin, you absolutely cannot wait for an accident to happen to fix a problem. You have to identify and fix the systemic issues long before the accident occurs. And the only way you do that is by analyzing near misses.
Oh.
Yeah.
Like the time someone almost tripped over an unmarked cable.
Yes.
Or the time a wrench was dropped from the scaffolding, but thankfully didn't hit anyone on the ground.
Exactly. But if workers are terrified of being fired or punished for reporting a near miss, what do? They
sweep it under the rug, they pick up the wrench, look around to make sure nobody saw, and just get back to work.
Exactly. Fear kills data. If you punish the worker who comes forward to say, hey, the lifting procedure we're using almost caused a crane to tip today, you lose the opportunity to fix the lifting procedure.
That makes so much sense.
The system prioritizes the free flow of critical information over the emotional satisfaction of punishing an individual. Because if a punitive culture drives reporting underground, the next time that wrench drops, it kills someone.
So the blame-free culture shifts the focus from who did something wrong to what flaw in our system allowed this to happen in the first place.
Precisely. And this philosophy is directly tied to the concept of proactive intervention and universal stop work authority.
Right.
The rules mandate that absolutely everyone on the site, from the newest apprentice sweeping the floor to the senior site manager, is authorized to stop work immediately if they doubt safety.
And without any adverse consequences or fear of retaliation.
Right.
That is a massive structural transfer of power to the ground level. It democratizes safety.
It really does. Now, you asked earlier if this means there is no punishment ever and that careless people just run wild. The answer is no.
Okay.
The documents have a very nuanced, structured view on what they call consequence management.
Right, consequence management. I noticed that specific phrasing in the sources. Consequence management, or disciplinary action, is only considered if the organization has already provided all the necessary physical and cultural enabling conditions, and the worker still flagrantly breaks a rule.
Exactly. The organization must prove it provided the correct training, the right tools, sufficient time to complete the task safely, and clear expectations. If management failed to provide any of those enabling conditions, they cannot punish the worker for a failure.
The system essentially states, we must first prove that we did not fail the worker before we can determine that the worker failed the system. It holds the management structures just as accountable as the boots on the ground.
It treats human error as a symptom of a systemic flaw, rather than the root cause of the problem. That is a profound paradigm shift.
We must first prove we did not fail the worker. That totally flips the traditional corporate script.
It really does.
And I think that's a perfect place to pull back and look at the bigger picture. As we wrap up this deep dive, for you listening, consider how you can take this heavy industrial framework and apply it to your own life and career.
Oh, absolutely.
You might not be building a billion-dollar refinery or dealing with high-voltage commissioning, but whether you are managing a corporate merger, rolling out a new product line, or just leading a small creative team, these principles are incredibly powerful tools.
Because the underlying psychology and system designs are universal.
Think about the step back 5. Before you launch a major project, take 5 minutes to mentally scan the environment for hazards. What could go wrong? What are the second-order effects? Or the ALARP analysis?
Right, the one step too far.
Exactly. When managing risk, intentionally map out the one step too far option so you know exactly where your practical boundaries lie.
And perhaps most crucially, fostering a blame-free reporting culture within your own teams.
Yeah.
Because if your team members are hiding their near misses from you because they are afraid of your reaction, you are flying blind. You will never spot the negative trends that will eventually cause a critical failure in your project.
Fear kills data. If you punish the messenger, you blind yourself.
But if I may, I'd like to leave you with one final thought to mull over. A bit of a paradox hidden inside all of this.
Oh, I love a good paradox. Lay it on me.
Well, we've spent this time marveling at this incredible preventative architecture. The risk matrices, the ALARP processes, the physical red spades, the 9 unchangeable life-saving rules, they are all brilliantly designed to perfectly account for and control human error.
They basically engineer the unpredictability out of the human.
Right. But this raises a fascinating question. If we successfully engineer our management systems to be this rigid, standardized, and perfectly protective, do we run the risk of making workers completely reliant on the system?
You mean like complacency?
Even deeper than complacency. If the system does all the thinking for you, if a matrix tells you exactly what the risks are and a bridging document tells you exactly how to act, does it ironically erode your natural situational awareness?
Oh, wow. Yeah.
If you are told exactly what hazards to look for, you might stop looking for the unexpected hazards that aren't on the checklist. It is a very fine line between a safety net that reliably catches you when you fall and a blindfold that prevents you from seeing the edge of the cliff in the first place.
Wow. The blindfold versus the safety net. It brings us right back to the beginning, doesn't it?
It does.
We can sequence the DNA of the project, we can engineer the perfect bureaucratic system, and we can bolt on all the red spades we want. But the human mind will always be the most unpredictable and really the most essential variable on the site.
Well said.
Thanks for joining us on this deep dive. We'll see you next time.
See the link in the description for free PDF download. Also, watch our other construction scope videos. Thanks for watching, please subscribe, and see you next time.